All right, we're rolling. It's almost clear now. I know I started it and not actually doing anything important. All right, so the first thing we're going to do is I'm going to need 3 volunteers, and so while you're debating whether you want to volunteer or not, I'm going to walk into the other room, and we're going to make sure that we record basically an empty board, or near empty board.
Who wants to volunteer?
I'll be one of the volunteers.
All right, so do I have 3 volunteers? 1, 2, 3. All right. For the sake of the video, we're about to go into the hallway to do the rope demonstration. In frame, somewhere from about here to somewhere around here. All right. Oh. One other thing. So why was Bilhah able to thwart the plans of Penelope and Ariana? And I'm going to close the door. All right.
Was it because of pressure? Like, just pushing down on it, you know, their principle?
Sorry,
Like, cause she was pressing down and they were pulling. It's like pressure versus pull, I don't know.
you've hit some key words in there. Pressure is probably not the right direction to go in right now, although it all connects. But let's stay away from pressure at the moment. You hit some of the key things. Anyone want to fill in the pieces?
Because we were both pulling so tightly, and the rope was, specifically because the rope was so long, by the time you get to the middle, it was pretty still with all the force acting upon it, so when she added the pressure of pushing down, we didn't really affect the middle because of how far away we were.
Oh, as in the force that you were applying sort of dropped off the farther away you go? Actually, I think if you put force sensors in the middle of the rope, the tension that you two were exerting was about the same, and the tension throughout the rope was probably the same. So that actually is not going to be a major effect.
I think the force I was applying was more powerful than maybe the force that they were applying across the rope was divided.
Now, I saw them and they looked like they were straining. Now, it's possible they were acting. And it looked like you did it pretty easily.
Yeah.
So, are you saying that you're a superhero and it's effortless?
Maybe.
Okay. I'm seeing people dancing around the answer here, but I feel safe in saying that the forces they were applying were greater than the force you applied.
Was it the direction of the force?
Keep going.
That's all.
Oh. Fill that out.
The two were going to the sides and hers was going down, so it didn't really go against the two.
Where was almost all of her effort fighting against?
Going backwards rather than keeping it up.
In essence. Yeah, they were fighting against each other. Almost their entire effort was against each other. And she just strolls in and does something different. Because we're dealing with a force, and direction matters. That is the key takeaway here. The force that was being exerted by Penelope and Ariana was horizontal almost completely. Initially, it was horizontal. Bilhah was doing a vertical force. In order to fight a vertical force, you need another vertical force that's going in the opposite direction. So if she was pushing down, there needed to be some force going up in order to stop her. Now, as you were pushing, was it easier when you first started to push down or at the end, or was it pretty much the exact same?
I really couldn't tell. I think it was easier towards the end.
You are a superhero. Wow. According to physics, it should have been more difficult the farther you bend it. So, let me ask you again. So, and then I can edit the video later. So was it harder the farther you went?
Yes.
Oh, there we go, just like it was supposed to. You also notice in physics demonstrations, there was my first semester here, I was teaching a 110 class, and the person happened to meet my wife, and the student said, yeah, I feel like all class long he's just going, this worked before. That's basic, the nature of physics demonstrations. They worked before. Because at the end, this is why the physics says that it should have been more difficult the farther you go. At the end, the rope is basically like this. Penelope is applying a force in that direction. Ariana is applying a force in that direction. Part of their force is upwards. So they finally, once the rope deflects, there is some force that they're applying to try to fight it. Now the other thing that matters is magnitude. Amount, basically the number with units. Because we have these two things. We have direction that matters, so the direction of force is applied does matter, and how much force is applied, that's the magnitude piece. We are now branching into the world of vectors. How many of you have dealt with vectors before? Okay. How many of you have dealt with scalars before?
What?
Scalars. And I will say this, all of you have dealt with scalars. I'm willing to bet an entire year's salary on the fact that all of you have dealt with scalars before. Scalar math, those are scalars. With a scalar, the difference between vectors and scalars is for scalars, direction doesn't matter. So this is magnitude only. I will be using the terms vector and scalar throughout the course and in the videos. So just be aware that when I mention scalars, I'm just talking about the math that you've been doing for years. But the vector stuff is typically new for Physics 110 students, unless you've had physics before. Math, you might have dealt with vectors, but probably not unless you've gotten to, I think Calc 3 starts dealing with vectors. Much more complicated than what we're doing. All right, here's a quick example of some vector math. I walk 3 miles, you know what? Because we're cool, we're gonna use metric. 3 kilometers east, then 2 kilometers west. Where am I? Relative to where I started.
1 kilometer east.
Vector math right there. What was the distance that you traveled?
5 kilometers.
Scalar math. So when you take direction into account, I start someplace right here, and I'm just gonna go with the traditional east is that way. Go 3 kilometers this way, and then 2 kilometers back. So 3 kilometers east, 2 kilometers west. Where do I end up? but 1 kilometer east of where I started. So now let's make it look far more complicated. And that's not to scare you, it's just to say that, yes, it might look more complicated, but it's not as complicated as the notation dictates, or makes it seem. And by the way, the little sneak peek ahead from chapter 3, this right here is the displacement. Where an object is relative to where it started. All right, so now to make it more complicated, and we will go for another color just for that absolutely incredible visual effect. Ooh, blue and blue. Yes, that's a different color. Let's try this one. Yeah. Three kilometers east plus 2 kilometers west equals 1 kilometer east. That's too much to write. We gotta simplify that. I don't really want to write out east. So I'm just gonna say east. I'm just gonna do E with a little hat on it. That's the symbol to use. And then west, I'm just gonna put a W with a hat on it. Just don't have to write as much. Mathematicians and physicists don't want to write much. And so they use, what they write on the board is just to reduce the amount that they have to waste ink. They're saving the planet 1 pen at a time. So 3 kilometers east plus 2 kilometers west is equal to 1 kilometer east. Oh God, it's too much to write. Surely we can simplify this a little bit more. Before I simplify it one step more, any questions? So instead of using east and west, what I'm gonna do is I'm just gonna say to the right is, I'm gonna use an I, and I'll put a little, the hat on it. This is known as I hat. West is just the opposite way. Think about a number line. Flash back to whenever you did number lines. You have all these positive numbers on one side. What was in the opposite direction?
Negative number.
Yeah, so instead of writing west, we're just gonna say it's negative I hat. I hat's this way, so negative is just that way. So this now becomes 3 kilometers I hat plus 2 kilometers negative I hat is equal to 1 kilometer I hat. Now, it might not seem like I've saved a whole lot of ink there, but the saving's gonna come up next. Yes, Ariana?
Why is I hat the chosen notation for that?
Sorry, ask it again?
Why is I hat the chosen notation for that?
All right, there's two pieces to that I'm seeing. One, the hat is this right here indicates we are talking about what is known as a unit vector. Unit vectors it's a vector, so it has a magnitude and direction. The direction for this case is whatever I say it is. I said it's that way. On your paper, you could have made I hat that way. You could have made I hat up, but that probably wouldn't help you a whole lot. So if you see the hat over a vector, you're talking about a unit vector. The magnitude of a unit vector, the hint is in the name, unit. Anybody want to take a wild guess at what the magnitude is?
1.
Yes. No units, just 1. So the whole purpose of a unit vector is to indicate direction. So that's why I have something with a hat over it, is this is telling you, hey, I'm defining a direction. Now why I hat? There are a couple of standards that our textbooks use. One of them will use X hat, Y hat, and Z hat. Others will use I hat, J hat, K hat. I prefer the I, J, K instead of X, Y, Z, is because too many people have been brainwashed with X, Y, Z, where it might be more convenient to make that direction. And so if I start using I hat, I'm hoping to break students of this idea that it has to be everything in terms of horizontal and vertical
Thank you.
and depth. There are a couple other standard notations. If you get far enough, and this is why I generally don't do them, instead of I, J, and K, there's sometimes they'll use H sub 1, H sub 2, and H sub 3, or E sub 1, E sub 2, E sub 3, well beyond anything that we will ever come close to. So I had. Now notice I got the same units here across the board. I start in kilometers, I'm gonna end in kilometers. I don't have to worry about units. I could have just written this as 3 I hat minus 2 I hat is equal to 1 I hat. And this is where the savings comes in. We actually have one more step that we can do in this case to save a little bit more ink. Now, I do want to point out, this right here is indicating 3 kilometers, because that's understood, 3 kilometers in that direction. Negative 2 I hat, the negative is part of I hat here, but typically you write it in front. So to make it look more like an algebra equation. So negative 2 I hat means 2 in the negative I hat direction, or opposite I hat. And so 3 minus 2 is 1. The other thing I want to point out here is you do need units in the final answer. If you left it like that, on a 10-point problem, minus 3. Units are important. This is a big differentiation between physics and math. In physics, units matter, where appropriate. You don't have to keep track of units in the middle of the problem. You do need units at the end. So my final answer, 1 kilometer, I hat. Now, I hat is not always that way. I hat is whatever I say it is. Or, in your case, when you're doing the problem, whatever you say it is. But because I defined I hat already, I don't need to I don't have to go back and go east, because I already said I hat is that way, and I have 3 kilometers in the same direction, so I think understood that I hat is east. And one more shortcut. This last shortcut works for a one-dimensional problem. So for a one-dimensional problem, so the whole thing's taking place along a line. You can get away with what I mean by this with plus minus is I could have, since it's a one-dimensional problem, it's just traveling one direction and then the opposite direction, I could just get away with just saying to the right is positive. And so now my problem becomes 3 minus 2 equals 1. And then I have to throw in units at the end. Done. Questions up to here before I make it seem more complicated?
Would you use it for north and south too?
If it's a north-south problem, yeah, you can do it there too. You can make
So
whichever way you
just
like.
use the I?
Pardon?
You use the I for north and south too?
I would.
Okay.
If that bothers you, pick a different letter. But once because you're gonna find it, I mean, you could go with Q hat, just assuming that you can, yeah. You can do Q hat, just, it's not traditional.
Could you get away, for the one-dimensional problem, if it's going up and down, could you also get away with that notation, using positive and negative?
If it's just an up and down problem, yes, absolutely.
When you're saying one-dimensional, are you meaning like a plane? So,
So one dimensional is just along a line, so you're traveling one direct, your
okay,
track starts out in some direction, so it's either gonna travel in that direction or completely opposite.
okay, yeah.
Two-dimensional would be in a plane, three-dimensional is in space. But most of the three-dimensional problems can be reduced to two-dimensional problems at this level. So if I throw that into the air like that, it's called a projectile motion problem, chapter 10. As it's going through the air, it might seem like a three-dimensional problem because you got the board here, you got up, down, you know, the wall's basically sort of define a space here. But you can always take any coordinate system and rotate it, so now it's all within one plane. Other questions before I make this look scarier? I have a 10-kilogram box here. I have a 3 Newton force acting on it that way, and I have a 2 Newton force acting on it that way. What is the total force acting on the box? You can just word it out.
1 Newton?
So close.
5 Newtons?
Yeah, not 5.
One Newton to the right?
There we go, direction. Unless, of course, you were assuming that to the right was positive. But you didn't state